I'm Florence Dowrick, a MajorTim.space honorary young ambassador. This is Noah Khanzadi, a MajorTim.space young ambassador. Today, we are delighted to be interviewing Neil Gostling. Neil, could you please introduce yourself?
Hello, my name's Neil Gostling. I'm an associate professor in evolution and palaeobiology at the University of Southampton.
Thank you. This is my first question for you. Your work combines evolutionary biology, paleobiology, and developmental biology. What attracted you to these specific subjects?
Oh, that's a really good question. I think so. Evolution underpins all of biology. Without
Mm,
the idea of natural selection, which Charles Darwin published in 1859, there wouldn't be a subject called biology because we wouldn't have a mechanism to put everything together. So before 1859, people had lots of ideas about life on Earth and how living things came to be, but they were just so stories. This is how this happened, this is how that happened, but no one really understood. With natural selection in 1859, we've now got a mechanism for understanding how life changes, how life interacts, how different species interact with different, how animals interact with plants, how
yeah.
plants interact with animals, microbes, all sorts of things. It's just this beautiful, wonderful subject that allows us to understand how life has got to be as it is today. How does paleobiology come into it? I'm interested in extinct things, amazing
Mm.
animals, amazing plants which aren't around now, and studying them as they would have been when they were alive. I'm interested in them as living organisms, as parts of an ecosystem. And so why wouldn't I be excited in that? It's just wonderful. And then development, there's a wonderful saying when people were putting forward evolution and putting forward this idea of
Yeah.
how we start off as very, in history, very simple single-celled organisms, and then we're through to humans with hundreds of billions of cells. And there's a story of an academic giving a lecture, and at the end of it, a woman stands up and asks the question. Well, of course, this is all very good, but how can you possibly expect us to believe that a single cell over time has evolved and such that now we have this wonderful complex world? And his answer was, and it's a fun answer, but he said,
Yeah.
"But madam, of course you did it yourself in 9 months." You go from a single cell to now it's not exactly the same, but
Yeah.
development gives us, it helps us to understand how you go from a single fertilized egg all the way through to this wonderful complex organism that can sit in a room and talk to two people about evolution and biology and space and everything else. So
Yeah.
fossils, evolution, development, they're the fundamentals of biology, and it's wonderful. I'm very lucky.
Yeah, I love how excited you are about this. It's getting real excited as well. Noah, do you want to ask the next question?
Of course. Here's my next question. How old were you when you realised you wanted to work within paleontology, and what
Oh,
motivated your passion for the subject?
that's a really good question. So, last week there was a very important person who had a 100th birthday, and that's David Attenborough. And I tell this story over and over again. In 1979, I know I'm that old. It's hard to believe, but I am. Um, I was three and a half, and my mum sat me down in front of our black and white television and put on Life on Earth with David Attenborough and all of these wonderful things. And what in the first episode, there's this weird bird that lives in South America called the huatzin, and it's got claws on its fingers, and it makes this nest, if you can call it a nest. It's some sticks balanced on a tree above the Amazon and Orinoco river basins, and it
Mm.
lays an egg, and the egg hatches, and this ugly chick comes out of it, and the ugly chick is a bit stupid, and it falls into the water, and in the water there are caiman and piranha fish,
Yeah.
and so normally that would get eaten, but it sort of swims over to the edge, finds the tree, and climbs back up with its little claws on its fingers, and then it cut to Archaeopteryx, which is this the first bird 150 million years ago. 12 specimens of it have been found from Germany. It's just this wonderful skeleton with a long bony tail and teeth in its jaws and 3 fingers with claws on, covered in feathers. It's a dinosaur covered in a bird's clothing. It's the first bird. It's wonderful. So when did I get excited? When did I first think about all this sort of thing? When I wasn't even 5 years old, watching things on television, David Attenborough, going to the local park, and in the park there was a fossil pit, and you could find 40-million-year-old shark's teeth. So I think, so from before the age of 10, I was excited about fossils. Yeah, and I it's just sort of ballooned from there.
Yeah.
I can say I had a similar experiences. As a kid, I used to collect lots of like bird feathers.
Yeah.
Yeah, and a lot of it stemmed from watching David Attenborough at a young age. But yeah, I love all his shows. They're great.
Yeah.
Much of your research focuses on the evolution of dinosaurs and the origins of avian flight. Have you been surprised by any of the recent Have you been surprised by any of the results of any recent discoveries?
So I'm amazed about. So I live in Southampton. I'm at the university. I am, as the crow flies, about 4 miles from the Isle of Wight. So that big diamond lump of rock sitting at the south of England. As you look across the middle of it from east to west, there's this ridge, and the rocks in the north are young. There are sort of modern rocks back to about 50 million years ago. Across that ridge, though, go across, and all of the younger rocks are missing, and you go straight back to about 120 million years, all the way back to about 130. It's wonderful. And if you're in rocks which are 130 million years old, and they're terrestrial rocks, they're deposited on land, there's a good chance that any fossils that you find in them will be dinosaurs, or they could be monsters. And so the dinosaurs, they're there. And you drive across, and what's wonderful about the Isle of Wight is we don't really think about it as it being this sort of wonderful, important place. It's the Isle of Wight. It's where people go on holiday, have an ice cream. If you think about dinosaurs, you think about the Badlands of Montana, North America, China. Well, the Isle of Wight is in the top 10 places in the world for dinosaurs. They're right there. So I think one of the things I'm most excited about and most surprised about is how many dinosaurs come out of the ground. Now, my first dinosaur paper was published in 2020, so that's 6 years ago. In the last 6 years, 10 new species have been described from the Isle of Wight. Now, more species have been described from other parts of the world, so from Montana. But Montana's huge. It's an enormous, great lump of North America. The Isle of Wight, the rocks where the fossils are coming out, it's about 5 kilometers of rock. The cliffs are eroding. So that's remarkable. That's really amazing. They're there, they're on the beach, they're falling out, and that's where we're getting things like this from. I'll tell you all about that in a minute if you're interested. But we're finding the snouts of spinosaurs, we're finding the bones of iguanodontids, we're finding the armor of thyreophorans, we're finding great big vertebrae from sauropods, and all of their footprints. Yeah, it's remarkable. I think so. The thing that surprised me the most is how fossiliferous the Isle of Wight is.
Yeah. Before we move on, can I just see what you were holding over earlier?
So this is the rostrum, the snout, the premaxilla of a spinosaur called Ceratoseucops, and Ceratoseucops means horned crocodile face. The whole name is Ceratoseucops infrarodios, the horned crocodile-faced hell heron, because it would have been standing in the shallows with its snout above the water, and then as a fish goes past, ka-chunk, bites it and catching this fish. So it's got this really weird rosette of teeth, classic Spinosaur. And you can see, I don't know if you can see here, this is a 3D print. There's a tooth here, and if you look at the tooth, it's round. Most theropods, the carnivorous dinosaurs, have teeth which are blade-like and serrated along the front and the back. It's like a steak knife, and it's evolved like that because basically what they're eating is giant dinosaur steaks. And so having a tooth which can just pierce into and take great chunks of iguanodon or sauropod or other theropod, younger, smaller, tastier theropods. Having those teeth is really useful. These animals eat fish, and if you look at fish eaters, crocodiles, dolphins, all these animals which are classic fish eaters, they have round pointed teeth, exactly the same as spinosaurs. These round pointed teeth show that this is a fish eating animal. So yeah, this is remarkable. This is Ceratoseucops premaxilla from the Isle of Wight.
Thank you. Noah, would you like to ask the next question, please?
You have featured in documentaries by Sir David Attenborough and Steven Spielberg. Can you tell us a little more about your experience of working with such legends within the film and television industry?
Yeah, I mean, this is it. So when I was, as I was saying to the first question about what got me excited about this and doing what I'm doing, it was watching David Attenborough documentaries. So when I was given the opportunity to talk about the Sea Rex, this large pliosaur which has literally fallen out of a cliff in Kimmeridge in Dorset, and they asked if I would be involved and if I could do some work and describe this and be in the program with David Attenborough. I mean, how wonderful is that? I mean, he is the voice that explains nature and science documentaries for my entire life, and for my, going back to the 1950s. I think before my mum was born, David Attenborough was on the television talking about exotic animals and all sorts of amazing things. So that was brilliant. It was amazing. The thing that was really weird about it was that David Attenborough asks the questions. Normally, David Attenborough gives you the answers.
Yeah.
Okay. You think, oh, I wonder what this could be. He's already thought about that. That's what they're telling you in the documentary. But this was the remarkable thing. He was asking me the questions and I was giving him the answers. It was all back to front. It made no sense. What do I do? Why am I telling David Attenborough stuff? It was what a wonderful experience, and what a lovely, lovely man. It was. They say never meet your heroes, because no, he didn't disappoint. He was just wonderful. He was everything you would imagine he would be. He was kind and thoughtful and asked sensible questions. It was just the most wonderful day. I'm incredibly lucky. And the Steven Spielberg bit, well, I never got to meet Steven Spielberg. I never got to meet. He produced this wonderful program called The Dinosaurs, and I was very lucky because two of the major scientific researchers involved in that program, a chap called Tom Fletcher and another chap called Tom Land, I have over the last 20 years taught both of them. And Tom Land most recently, and he got in touch with me and asked if I could give some advice and some information about the spinosaurs that he wanted to feature in the program. So we talked about how they might have eaten. In the snouts of these animals, you can see all these pits. Maybe they're sensory. Maybe when the animal's in the water, it can sense motion. Crocodiles have pits all over their faces so that they can detect pressure changes and where a fish is coming from. Maybe spinosaurs were doing something similar. So we suggested that this was what they might be doing, and that's what ended up in the program. Incredibly exciting. I didn't get to meet Morgan Freeman either, but it's very nice to have my ideas based on the research that people in my lab and colleagues have been doing, to see that on the screen. Absolutely, I'm very, very lucky.
Yeah, I can't imagine.
Yeah.
Honestly, I have the best job. Then I get to talk to people like you, which is wonderful as well, because it's not just people who've influenced me. I get the chance to talk to people as well, and so it's a huge privilege because I get to make, have what I say people might listen to as well, and you never know, it might be that people hear me and then they want to do. And how lucky am I that I can get to do that? It's wonderful. I'm very lucky.
You have used technologies such as high-resolution CT scanning and experimental taphonomy in your research. How are modern imaging techniques changing the way we understand fossils?
That's a really good question. So let's go back 100 years. In
Mm.
1920s, 1930s, there's a fish called Eusthenopteron, and it's closely related to us. It's a lobe-finned fish. It's got big fleshy fins, and potentially it could have dragged itself out onto land a little bit. It's a funny round-shaped fish, so it wasn't living on land, but it might have been able to drag itself out. There's a couple of documentaries where it has that, and it comes out of the water and grabs some poor silly amphibian that's wandering too close to the water's edge. But Euthenopteron is this huge thing, and it's really long. It's a good couple of meters often in like sort of bits of it, and it's sort of 25 sort of I don't know, 30 centimeters in diameter. It's a really big fish. And Jarvik and Stensio in Sweden took this fish and they ground off a millimeter, and then they drew what they should. And then they ground off a millimeter and they drew what they should. And they ground off a millimeter and they drew. And so they're getting all these slices all the way through the fish. And they were able to build up this 3D model of the internal structures of Eusthenopteron. Really important. What's its brain look like? What are its nerves going? What the blood vessels doing? All this sort of exciting stuff. Really important. The fossil's gone. It's destroyed. It's literally been ground through to nothing. CT scanning allows you to do exactly the same thing, to produce a lot of slices, and then using a computer you can connect an image in slice 10 with an image in slice 5 with an image in slice 1, and so you can build up at the way that shape, that structure changes in 3 dimensions, exactly the same as what Jarvik and Stensio did. But the beautiful thing is, I put my fossil into the CT scanner and it comes out of the CT scanner in exactly the same state. As long as you don't drop it, as long as you don't have an accident, the fossil remains. And you can do that with anything that you can CT scan. What's beautiful, I mean, it's exactly the same technology as if you break your arm or something, or you don't have to break your arm. You could just go to the hospital and be put in a CT scanner and we could see what's inside you. But if you're the most likely time you would go and have a CT scan is if you've got some injury and they want to see what's going on inside. It's exactly the same technology, but there's more energy involved, more powerful X-rays blasting their way through my 125 million year old fossils than there are that you can blast through people. People don't like lots of X-rays. That's not good for them with the energies that we're talking about. An X-ray, no problem. 450 kilovolts, too much X-rays. So we can blast through, we can detect the image, we can produce this grayscale image where you can find structures in one place. You can then look at the next slide and find those same structures and link them all the way through. And you spend lots of time on the computer getting, going slowly blind as you need to get better glasses to be looking at all these little pixels. And you can build up these wonderful models. And we've done that with our spinosaurs. We've looked at the brain cases, we've put them back together. We've, after 125 million years in the ground, skulls are often a bit squished. So we've retro-deformed it and put it back to the shape it should be. We've then filled in the hole where the brain would have been. So the endocast, which is the brain and all of the soft tissues. And so we've made, we've found out the shape of the brain. We've found out the semicircular canals, which are part of your ears and allow you to balance yourself. We've looked at all the structures, how the sensory organs and the sensory, the neuroanatomy of these animals to see how they could sense the world around them, how well they could smell, how well they could fix their eyes onto it. So there's all sorts of things that we can do with CT scanning, which you can't do in any other way. And beautifully, it's non-destructive. So what goes in should come out. It's lovely.
Yeah.
No, do you want to ask your next question?
Yeah. Given the established evolutionary link between birds and theropod dinosaurs, what aspects of this relationship do you find most significant in understanding modern avian biology?
Well, this is it. I think one of the things we always think about, life, and we think about things which are closest to us. So we talk about animals. Animals are everything which isn't plant or fungus and has, is multicellular. But we often refer to animals as mammals, really, and mammals, animals plus reptiles and birds. Well, no, they're all animals. there are only about 5,000 species of mammals. There are about 6,000 species of amphibian. Similar number of reptiles, I think. Birds, how many birds? There's 27,000 species of fish. Okay, that's great. But birds, of the animals that live on land, 5,000 mammals, 6,000 amphibians, similar sort of number of reptiles. How many birds are there? 11,000 named species. 11,000, that's more than double the amount of mammals that we have. So I think one of the things that's really exciting about that to me, which means, and why birds are so fun, is birds are dinosaurs. There are twice as many species of birds as there are mammals. We're still in the time of dinosaurs. Hooray! And so they're not quite as terrifying, unless you bump into a cassowary, I suppose. They're not quite as terrifying as Velociraptor or Spinosaurus or any of these, T-Rex. Yeah, I wouldn't want to meet T-Rex in a dark alley. I don't think that would end well. But to be fair, to be fair, I probably wouldn't want to meet a chicken in a dark alley. Chickens are incredibly aggressive. They're oh, we might have them for Sunday lunch, but they you don't want to get on the wrong side of a chicken.
Raised chickens, they're very vicious.
Absolutely. There's a video of chickens catching mice. They are merciless. So mammals don't come out well when they face off against theropods. I think the thing that's most exciting to me is that we have all these characteristics. So the reason that Archaeopteryx, when it was discovered the feather was discovered in 1860, a body fossil covered in feathers, which you can see at the Natural History Museum in London, was discovered in 1861, 2 years after Darwin published The Origin of Species. The thing that everyone said, oh, it's a bird, was because it has feathers. And the only living group of animals that has feathers now are birds. So feathers are a characteristic of birds. But it turns out they're not. Feathers didn't evolve in birds. Feathers evolved not even in dinosaurs. Probably the last common ancestor of dinosaurs and pterosaurs, because pterosaurs have something which looks suspiciously like feathers. So there's a characteristic of a group called Ornithodira, which are pterosaurs and dinosaurs. So the thing I think is most exciting is that feathers, this characteristic that we only see in birds today, is way, way older. Okay, it goes right the way back 250 million years. It's there in the last common ancestor of dinosaurs and pterosaurs. And I think the other thing that's exciting about sort of dinosaurs and flight, not necessarily specifically about birds themselves, is that flight has evolved on numerous occasions in dinosaurs. Okay, pterosaurs doing it very well, separate evolution. But dinosaurs have evolved at numerous occasions. We've got Microraptor. They're not birds. We've got Yi-Ki. That's a really weird dinosaur, which it has probably some feathers on it, but it has these wings made out of membrane between long fingers. It's almost got like bat wings. It's the weirdest thing. So flight is clearly very advantageous because lots and lots of groups of theropods alone, let's forget about everything else, lots and lots of groups of theropods have evolved flight. Yeah, I mean, that's fun. It's fun. Birds are cool. And birds are dinosaurs. And
Yeah.
As someone who is deeply involved in teaching evolution and palaeobiology within universities, what do you think is the biggest misconception amongst students and the general public?
Oh, that's a good one. Oh, goodness me. What's the biggest misconception? Oh, excuse me. The biggest misconception. I think that the idea is that evolution can't be real. And I don't think this is from students, because I think once you become a biology student, you've kind of accepted that evolution is a thing. You've just got to. But this idea, people who don't accept evolution, oh, well, we've never seen a cat evolve into a dog, or we've never seen this evolve. That's not how it works. And we don't see suddenly new animals appearing all the time. No, we don't. At the beginning of the Industrial Revolution, so when we started digging up fossil fuels and burning them for to make the factories work, and we pumped lots of smoke into the atmosphere, and it made everything very dirty and polluted. There was a moth, Betuleria. It's a white moth with black speckles, and normally it sits quite happily on birch trees, silver birch trees in particular, and the white moth hides on those on that bark and can't be seen. There are black individuals in the population, and they'll not often sit on darker coloured trees. But if they sit on a light coloured tree, then birds find them and eat them. During the Industrial Revolution, that flipped, because all of a sudden, nice silver birch trees were becoming covered in soot and dirty. And so the white moths stood out against the dirty background, and the black moths blended in much better. And so there was a shift in the population from white moths to darker moths. And then in the 1950s Clean Air Act, we start cleaning the air up, and there's a shift back from the black moth to the white moth. And people get upset and they say, well, that's not evolution, it's a moth, it's still a moth. It is. But that's not what evolution is. Evolution is a change in allele frequency. So the variation of a gene. Alleles are the things that give us blue eyes or brown eyes, dark hair, light hair. I don't know why I've got dark hair here and light hair here. I think that's age. But anyway, it's not genetic. But blonde hair and dark hair and so on and so on. Well, a change in the population of the amount of individuals that have blonde hair against brown hair, if that shifts so that all of a sudden, rather than everyone having brown hair, everyone's got blonde hair, that is a change in the allele frequency. If you change from white moths to black moths, that's a change in the frequency of the white allele against the black allele. That is evolution. Now, if you have lots and lots of these individual little changes, and they all go on, and they're all selected for, and they're all passed on, then you will, over time, the population will change from one form into another form. That's evolution. So microevolution and macroevolution are exactly the same thing. It's exactly the same mechanism controlling it. And I think there is this misconception in the public about what evolution is. Everything's got to be changing from a fish to a duck. That's evolution. No, that's not evolution. That's not how it works. And so I think understanding and explaining these things, that's what's fun. That's what I get to do. And it's really nice when you are explaining things to groups of people. I find it very nerve-wracking still. I've been doing this for, 25 years, I suppose. But it's no less nerve-wracking to stand in front of 150 people, 200 people, and explain things to them. Because, again, I think we've evolved from our ancestors who were hunter-gatherers and people going out in little groups to go and hunt a mammoth. And you might have had small family groups, and you would have talked to each other in various grunts and ugs. I think, to be fair, humans have always had fairly complex way of communicating. I don't think it's fair to have this sort of caveman image of people ugging and grunting. I think that we would have been small groups explaining what to do about what we were going to. I don't think we've evolved to stand in front of 250 people who don't really want to be in the room at that time and have no interaction going the other way. It's very odd to talk at people. But one of the things that's wonderful is, as I'm standing there feeling awkward, uncomfortable, and making a little joke to try and, to pass the time and to try and stay on side, please like me, as you're talking and you're saying something, and suddenly you see this sort of, and a spark goes off and a light bulb moment, and people get what you're saying and they understand it, and they become as excited about things as you are. It's wonderful. I'm so lucky.
Mm-hmm. Yeah. In 2021, you, alongside two other researchers, identified and named two new species of Spinosaur. What makes this particular discovery especially noteworthy?
Well, okay. So let's go back to 1983 to begin with. 7-year-old Neil is very excited because someone has just discovered a dinosaur about 20 miles from where I grew up. as the crow flies. If you drive around the M25, it can take forever. But as the crow flies, at about 25 miles thereabouts. And what they found was this heavy claw. And if you translate heavy claw into Greek, you get baryonyx. And this is a model of baryonyx's. We say thumb claw, it's not the thumb, they've got these three fingers, but the index finger has sort of become thumbish. Okay, this is a big old claw. It would have had a great big sheath over the end of it as well, made of keratin, the same stuff as your hair and fingernails. So the claw would have been absolutely enormous. This lived in a region where there was a river flowing south out of what's now London. It would have been in a forested region, catching fish, eating other dinosaurs, baby dinosaurs. We found fish scales and an iguanodon, a juvenile iguanodon vertebrate inside it. So it's there. It's very exciting. But just 60 miles away, as the crow flies, on the south side of the Isle of Wight, we found two more spinosaurs. What's beautiful, baryonyx is very complete. Baryonyx was sort of dug out of the ground. It was a bit mishmash, but it was all there. The Isle of Wight, the south side of the Isle of Wight, is eroding at about 1 meter per year, and bits of dinosaur fall onto the beach. And people find them and hopefully take them to the museum. And if they take them to the museum gets in touch with me and says, "Would you like to look at this?" And I say, "Yeah, I'd like to have a look at that." And what's nice is we've got a skull, a brain case, a snout, the rostrum, the premaxilla of baryonyx. We've also got the brain case of Ceratopsuchops and its nose. And we've got the brain case and the nose of Ripara veneta. Now, at the time, we had two spinosaurs which had been found on the Isle of Wight. And we have baryonyx described in 1983. So there's nearly 40 years. Well, there's about 40 years between publication, but there's what's really nice is if you have the tail of one dinosaur and the head of another dinosaur, you can't do anything with that. You can't say this dinosaur didn't belong with this dinosaur, and you can't overlap. You can't, because they're two totally different things. If you've got three skulls, you can start to compare and contrast and say, this is the same as this is the same as that. So the ones from the Isle of Wight, we looked at and we said, they're not the same as baryonyx. This is great. So we've got a new species. And then we looked a bit further, and there are differences between Ripara veneta, specimen B, and specimen A, which we now call Ceratopsuchops. So they were found on the same beach. One was found just lying on the beach. One was dug out. But the whole section is 4 million years. We don't know where in the section the one lying on the beach actually came from. So there could be 4 million years different between. They never met. I guarantee you that those two things were never walking along. They were never walking along the same beach. Okay, so we've got these two skulls which are not the same species. We've got baryonyx, which is not the same species. If you go along the beach as well, so they're all three of them though are in an area called we've got the Wessex Formation for the two from the island. We've got the Wealden Formation for baryonyx, the Wealden section, and they're the same age, 125 million years plus or minus. If you go along the beach to the west on the island, you end up in younger sediments. And we've gone from this forested riverine environment to a place where the sea is starting to move back onto land. And we find another spinosaur. Now we've only got a few bones, few tail bones, some fragments of limb bone. We haven't got enough to identify a novel characteristic to say that it's a new species, but it's massive. It's about 13 meters long, which puts it in the same sort of size as Spinosaurus aegyptiacus from North Africa. It's big. And it's possibly a Spinosaurine spinosaur, like Spinosaurus as well. Very exciting. But it means that in the stretch of sort of 3 kilometers of beach, we've got 3 different Spinosaurs, which is really exciting. Now, lots of people get very upset and say, oh, but you can't have the same animals in, very similar animals in the same niches at the same. Now, number one, they weren't there at the same time. Ceratopsuchops and Ripara veneta are probably close, but they're not necessarily at the same time. The white rock Spinosaurids, again, it's 6 million years younger. So we've got these wonderful animals. But even if they were at the same time, if you go to Africa today, you've got leopards, you've got lions, you've got jaguar. No, you haven't got jaguar. They're in South America. You've got cheetahs having a moment. I don't work on big cats. No. You've got leopards, lions, cheetah. Now they're all doing things slightly differently, but they're all eating some kind of antelope. Why couldn't we have this in the past? Why can't the Spinosaurs be, sort of segregating themselves in the habitat? I think they absolutely are. I have no problem with there being multiple large theropods walking around on the south coast of the UK 125 million years ago. It's really exciting.
Climate change and biodiversity loss are major topics today. What lessons can studying past extinction events teach us about the future of life on Earth?
That's a really excellent question. I think that studying the past can inform us about the future, inform us about the present. Sorry, studying the past can inform us about the present and predict the future. We know that if a giant lump of space rock falls out of the sky and hits Mexico, it's game over for 3/4 of the species on the planet. We know that it doesn't matter how good you are in an environment when it's just going along happily. If there is a catastrophic change like that, and like that is not geological. So in hundreds of years, thousands of years, 10,000 years, still not a long time. 100,000 years, okay, that's probably time for things to start to evolve a little bit. But if we have rapid change of our climate, as we have since the Industrial Revolution 250 years ago, we have, what was really nice was there were all these fires, really high intensity fires in the Carboniferous, which burnt through forests, and they were so violent that they burnt all of the volatile chemicals off, all of the oils and all this sort of thing in the plants, and left behind the carbon skeletons of the plants, which fell over, got buried, and were locked away as coal. Hooray! Yeah. Lots of carbon from the atmosphere fixed into plants, buried in the ground. It was there for 330 million years. Perfect. We've come along, dug it all up, and have burnt through it in 250 years. That has changed the atmosphere quite markedly, and we are responsible for climate change. I think we've stopped using the word global warming now, because what we will see potentially, if we don't stop things, is that actually Britain is on the same latitude as Canada in the west and Siberia in the east. Both Canada and Siberia have really cold weather. And chances are we will have very cold weather as well. We're certainly going to end up with very different weather patterns. I think we'll have a lot more extreme weather. It will be very much hotter in the summer. It will be very much wetter and unpleasanter. Unpleasanter? I don't think that's a word. More unpleasant in the winter. So yeah, I think that that the past, it tells us what happens when we've had high levels of carbon dioxide in the past. The temperature has been higher. When we've had lower levels of carbon dioxide, the temperature has been colder. We can see what happens. And the thing that we do notice the most is that all of the mass extinction events, and there's been 5 big extinction events in the last 500 million years, they're all related to climate in some way, shape or form. So the last thing that I suppose, it doesn't matter really how successful you are in a given moment when the environment is all fine. If it changes rapidly, we are, species will go extinct. I think the thing that sets us apart is we know what we're doing, and there are people out there who are smart enough to come up with solutions. And I'm looking at people like you two, because you're interested and you're excited, and people in the generation, like sort of my parents' generation, my grandparents' generation, sadly now my generation, haven't done as much as we could have to sort things out. So it's going to fall to you guys, but you're smart and you're clever, and there will be people who will be able to turn things around. There will be people in my generation who pull a finger out and actually get on with making a difference. And I'm hopeful, because I think people can be brilliant. The wonderful thing that happened in the last month or so is that we put people round the moon again.
Yeah.
That's huge. That's brilliant. And it's not just putting them round the moon, it's bringing them back safely. That's really important. Anyone can fire a rocket around the moon. That's no problem. Bringing everyone back alive and well. That's what we're aiming for. And we can do it. And humans can be brilliant. We can be awful and rubbish and terrible and stupid, but we can be brilliant. And this is my hope that we will be.
Thank you.
Yeah.
Noah, would you like to ask your next question?
Yep. Can you give any advice for the best places to look for fossils in the UK?
Excellent question. So you want to find sedimentary rocks. So those are rocks that are things like limestone. So they've formed underwater, and little tiny particles have come down and buried animals, plants, what have you. So you want mudstones, limestones, chalk, all of these sort of things. Marine deposits produce fossils better than terrestrial deposits, because terrestrial land environments, things lie out on the land. Unless they're covered over very quickly, they tend to get eaten, or they decay and they get blown around. The wind damages them, then they fall to pieces and get disarticulated is the posh word for it. And the bones get moved around and scavenged and gnawed on and what have you. Beetles get into them and bore their way through. So if you're lucky, your dinosaur has died near a river, it's washed out to sea, it's sunk, and then it's got covered in sediment. That's a really good one for dinosaurs. But any marine environment, so the south coast is really good. If you're up near Yorkshire, that's really good. Got Jurassic rocks up in Yorkshire, so you can find ichthyosaur vertebrae, ammonites, all sorts of exciting fossils. I would, if you're near the coast and you're in a place where you've got sediments that preserve fossils, that's brilliant. And there's a website, I want to say that it's called UK Fossils. It's really good because it tells you the beaches, it tells you how to get there, it tells you how to get there safely, what you can find, what you should do, how you should, it's really good. Always go with your parents. Don't ever go on your own. Go with a group, let people know where you're going, make sure you take safety equipment, you're wearing proper shoes, you've got a helmet, you've got first aid kit, and that's someone who knows how to use it. Safety goggles, don't be hammering on places. It's never go to the bottom of cliffs and start hammering, always look further away from cliffs. So the best way to find fossils is go to somewhere like UK Fossils, look at what their guidelines and go with an expert group. If you go down to places like Lyme Regis, or you go to the Isle of Wight, there are groups of people who will take you out for fossil walks, and you will find things and you will see stuff, and they will tell you where to look, how to look, what to do. So that's I think the best places are on the beach, and the best places are with a guided tour. Once you know a little bit more, then that's fine. But
Yeah.
How do you distinguish between evolutionary signal and preservation bias when reconstructing ancient organisms from fragmentary fossils?
That's a really, really good question. So one of the problems is let's go back to the Cambrian. I've worked on fossils. So the Cambrian is 542 million years old. That's when it starts, and it runs through to about 490 million years. All of the major groups of animals, not species, but major phyla, the large groups of animals, appear in the fossil record in the Cambrian. A few appear later on, But that is in itself probably a preservation bias. It's not that they're popping up later, it's that they're just too small or they're soft-bodied or whatever, so they don't preserve. So we find lots of things that have got shells. Shells are made of calcium carbonate. They are hard. They are mineralized already. To become a fossil, you have to be mineralized. If you're already mineralized, you're already going for that. It's why we find invertebrates almost all the time, soft tissues are absent. We don't see skin or muscles or guts or what have you, but we see bones because bones are already mineralized. So there is a bias towards preservation. And you've got to be a bit careful, because the first thing you might say was, oh, in the past, life was just skeletons. There, soft tissues didn't even, I'm being silly, obviously, but you have to ask these questions. And what you need to do is to use modern analogues. So if you're interested in what features you could expect in dinosaurs, look at the modern groups, the things which are closest to them. So birds are obviously close. The next group that's closest to dinosaurs, which aren't birds, are crocodiles. So what characteristics do birds and crocodiles share? Because if they both have them, they were both in the last common ancestor. So it's likely that dinosaurs have them as well. And so we do this thing called using the extant phylogenetic bracket. So it basically means if you're looking at something here, what does this thing have? What does this thing have? If this has got it and that's got it, that probably had it too.
Yeah.
And it's how we work out about feathers, actually. If you look at birds have feathers. Now, there isn't an extant bracket, okay? You've got birds and you've got all the extinct things. But we've got pterosaurs over here. Birds, I can't do this from here. These are birds, these are dinosaurs. So we've got pterosaurs here, birds here. We know that these have got feathers or feather-like structures. We know that these have all got feathers because we can see them. So even if we hadn't found feathered dinosaurs, we could say dinosaurs almost certainly have feathers. Now we've found them in some groups. Now we haven't found them in sauropods. There's a good reason that we don't have feathered sauropods. There's a good reason that it's unlikely that the adult form of T-Rex had feathers. The bigger you get, the harder it is for you to lose heat. If you are a dice and you're 1 centimeter along each edge, you've got 6 centimeters squared of surface area to 1 centimeter cubed of volume. If you double it, now you've got 2 centimeters cubed of volume, but you've only got 10 centimeters squared. So you've gone from 6 to 1 to 5 to 1 as your ratio. Your surface area is getting smaller to your volume, so you can't lose heat so effectively. So if you are T-Rex and you're covered in feathers, you can't lose heat. It's why elephants aren't covered in fur, and why they have big ears, so that they can increase their surface area and they can lose heat. Sauropod dinosaurs, no feathers. But ancestrally and as juveniles, when you come out of an egg which is so long as a T-Rex, when you're a baby T-Rex, you hatch out of something like that. So maybe once you've uncurled, you're maybe, I don't know, 45 centimeters long as a juvenile. Being covered in feathers is really useful because you have a very high surface area to volume ratio. So although we haven't found feathers on T-Rex, we know we've got feathers here. We know we've got feathers here. We haven't found feathers on Diplodocus, but we've got feathers here and we've got feathers here. We've almost certainly got feathers ancestrally or as chicks. And I really like using the word chick for dinosaur babies that have just hatched. They've come out of eggs. We know that the behaviorally that there were dinosaurs, specifically theropods, one called Oviraptor, was almost certainly brooding and incubating its nest like a bird. So if it's like a bird, when they hatch, they can be chicks as far as I'm concerned. And I think the chicks would have feathers. I don't know if I've answered your question, but preservation bias, I suppose, and how we would answer questions.
Thank you. Yeah.
You have won many awards throughout your career. In your personal opinion, what would you say has been your greatest achievement so far?
That's really nice. I've not won that many. I've won some teaching awards, and I'm very proud of. I won the Vice Chancellor's Teaching Award a few years ago. that doesn't make me the best teacher in Southampton. It means that of the people who were nominated, I came out on top, and it was just really nice because it was voted for by my colleagues, students had put me forward. It's lovely to know that I'm having an impact and making a difference to people, and those people who are making a difference to our students. I'm in the position that I'm in because academics, colleagues supported me, and they don't need my support. They're far better and far higher up the ladder than I am, so I should help the people down, coming up behind me. And I think that's, if I get to do that, that's the best thing. And if my teaching is good, then I'm very lucky. I think in terms of societies and things I've managed to get into. I've got this. This is my Linnean Society badge. The Linnean Society is the oldest biological sciences society in the world. It's been going for a long time now. 1788, I think, was the first when it was founded. It's a lovely group for people to meet and talk about science. I'm going to a meeting tomorrow evening. So I grew up in Southeast London. I'm the first person in my family to go to university. I am hugely lucky to be able to do what I do, to talk to people that people might want to listen to me and think that what I've got to say is worth listening to. But that I get to go and sit in these old rooms and hear people talking about science and be part of that. It's wonderful, and I want to support and encourage anyone to have a go and to do that themselves. I'm nothing special. I've worked hard. I've got to where I am. Hopefully, I'll be able to keep doing what I'm doing. But if I can do it, then so can you. So can anybody else who's wanting to listen and who is listening. Sorry, and who wants to go for it. Grab these opportunities with two hands and just be brilliant. Be brilliant.
Yeah. You've kind of answered my next and final question, but we always end on one of these just to round it off, so I'll ask it anyway. What advice would you give to young people interested in pursuing careers in paleobiology or evolutionary biology?
Right. What advice would I give? Stay in school, work hard. Find the thing you're excited about. Find that passion. Ask questions. Always ask questions. Don't stop. Okay, this is one of the things that possibly makes me very irritating, is that I'm still asking why. You hear this in kids. My little boy, oh, why? And the thing is that at some point, lots of people stop asking questions. Well, weirdos like me and my colleagues who are in universities are still asking why and how, and we're trying to get to the answer, to the root of these questions. And if you're excited about something, don't let anyone tell you you can't do it. If you want to be a paleontologist, be a paleontologist. Go to get your A-levels in STEM subjects. So science, technology, engineering, maths, biology, geology, all of these sort of things are really important. Go and do an exciting degree. If you want to do a degree, find a subject that you're excited about. Okay, find that thing that you're passionate about, which is going to get you up for those early morning lectures and keep you in till 6 o'clock on a Friday evening. Because unlike school, you have to go to school. Okay, you have to go to school. If you go to university, there's no one telling you to get up and go to lectures. If you decide you don't want to go to lectures, no one's going to make you. So you've got to find that thing that you're excited about that will get you up in the morning and get you into class. And ask questions, get involved with all of the, go and do as much as you can. Come and see your lecturers and say, are there projects I can be involved with? I've got some undergraduates at the moment which are going through CT scans of a crocodile skull, and they're going through a very old 200 million year old crocodile skull, and they're going through and they're segmenting out the brain and looking at all these sort of things. They will be involved in the publication and everything else that goes along with it. So get involved, ask questions, be excited, and grab every opportunity that you can.
Thank you so much. I loved coming here to speak with you. You've been amazing to talk with. It's
Thank
been
you.
really funny, and you're just really engaging. Thank
Thank
you
you very
so
much.
much.
It's so nice to talk to you both. It's lovely.
Thank you.
Thank you.
My pleasure. My pleasure. Thank you so much. Good luck with everything that you decide to do.
Thank
Just be
you.
brilliant.
Yeah. Besides, it's nice now and feels better that I've actually can say I've done an interview now.
You did brilliantly, Noah. It's really good. It's as good as any I've done. So thank you very much. You made me feel very relaxed, very happy. Thank you. That's the best thing. It's the best way to get your questions answered is to make your interviewee feel comfortable. You did a brilliant job.
Thank you.
The next time it'll be easy for you. You'll be, yeah, I've done this
Yeah.
loads. It's easy.
Yeah.